This topic is called triangle inequality property topic, I guess. Basically, it just means that if you are given three sides of a triangle and you know their measures, that it can only be a valid triangle if the sum of two sides is bigger than the third. So we're going to explore a couple different ways that we can check this out. So for one instance, let's say that we're given that one side is 23 inches, one side is 14.5 inches, and the third side is 9.2 inches. What we want to do is make sure that the sum of two sides, or any two sides, is always bigger than the third side. You can almost, you don't really have to go through all the steps of choosing two sides, adding together, choosing two other sides, adding them together, choosing the other two sides and adding together, because 23 plus any other number is still going to be bigger than 14.5 or 9.2. So you don't have to worry about adding the 23 to anything. What you really want to do is you want to choose the two smaller sides, which would be these guys, add them together and make sure that they're bigger than 23. We'll just do it out to make sure. I'm pretty sure that this is, remember, line up the decimal points. 5 plus 2 is 7. 14 plus 9 is 13. So we end up with, I wrote 12. Slow down. 14 plus 9 is 13, carry the 1, so that gives us 23.7. 23.7 is bigger than 23, so this can be a triangle. So these are valid dimensions for a triangle, and that's really all you want to make sure. Let's try another case. I probably don't need to scroll up. Let's say that we have the sides 17 feet, 9 feet, and 24 feet. Again, we don't have to worry about the 24 because that plus either of the other sides will be bigger than either of those other sides. So we find the two smaller sides. What is 17 plus 9? That's going to equal 26. 26 is bigger than 24. So those are valid answers or sides for a triangle. Let me scroll up and try another one. Okay, let's see if we have pen. Okay, let's say that we have 19 is one side, 5 is another side, and 14 is a third side. Again, we want to look at our two smaller sides, which would be these, and we want to add them together. 14 plus 5, that's going to give us 19. 19 is not bigger than 19, so this is not a valid triangle. Definitely not. It has to be bigger, not equal to. Alright, so that's how you would answer that. It can't happen. And let's just try one more. Let's try a little dotted line. Alright, 16.4, 7.9, and 7.6. Our two smaller sides are these guys, so we want to add them together. We want to line up the decimal points because we're not going to use a calculator. 9 and 6 is 15. Carry the 1. That's 15.5. That is smaller than 16.4, so again, not a valid triangle. So this is it's one of those triangle properties people tend to forget. They think that anybody can just make up any sides for any triangle and it'll work, and that's not true. The other thing about this topic is I've tended to see them like habitually on SATs or MCAS. They just kind of sneak in one of these questions, and it just might throw you for a loop if you haven't thought about it or considered it. But that's just the deal. Take the two smaller sides and make sure that they add up to a number bigger than the third side. Alright, let's look at this with a different slant to it. Alright, this time what I'm going to do is I'm going to give you a picture, and we're not going to know one of the sides, and we're going to come up with what possible sides can be possible. So here's a triangle, again, not drawn to scale. They rarely are ever. 8, 18, and x. So they want to know what, or we need to find out what values of x. What values of x are valid. Alright, so what do we need to know? We need to know that 8 plus x, when we add those two sides, has to be bigger than 18. We also know that 8 plus 18 has to be bigger than x. We don't really have to worry about the 18 plus the x being bigger than 8 because the 18 is already bigger than 8, so we don't need to write down that one. So we have two inequalities here. We have, we have this one here, and we have this one here. All we have to do now is just solve those. So for this inequality here, to solve it for x, we need to subtract the 8. And when we do that, we know that x has to be bigger than 10. So that's one of the values, or those are one set of possible values. For the second inequality up here, what is 8 plus 18? That's going to be 26. And so if we think about this, it says 26 has to be bigger than x. So let's flip it around and say that x has to be less than 26, but it has to be greater than 10. So it's basically gonna fall between, if you like number lines, because who doesn't, right? Let's say that's 0, that's 10, and this is 26. It's got to be basically between all of these numbers. And I'm putting open circles. So those are all the possible values for x that would totally fit for this triangle. So that's just a kind of nice visual to think. You can't just plop any number you want in for x in this triangle. If you plopped in 2, that wouldn't be valid, because 2 plus 8 isn't bigger than 18. If you plopped in 30, that's not going to be valid either. So you need to, because 18 and 8 is not bigger than 30. So it's kind of a nice little tool to know. And again, it's easy to forget for some reason. I'm not sure why. Let's try another one like this. Okay, let's make some room. There we go. Scoot, 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 scoot. Alright. Let's see, how about we'll do just any old triangle. I'm not trying to draw them to scale. We'll say this guy's 17, this guy's 13, this guy we don't know. Could be a gal, I don't know. Alright, so one of the restrictions is that 13 and 17 has to be bigger than x. That's one of them. The other one has to be that our smaller number, 13, plus x has to be bigger than 17. Those are the two restrictions. There is the third, where 17 plus x has to be bigger than 13, but that's just silly to write out, because 17 plus any number is going to be bigger than 13, unless, of course, it's a negative number, which you can't have a negative side on a triangle. So we just solve these. What's 13 plus 17? That's going to give us 30. And then we go to our other inequality. If we subtract a 13 from both sides here, x has to be greater than 4. So, x has to be greater than 4, but it has to be smaller than 30. And again, if you like number lines, who doesn't? They're just amazing things. We'll say this guy's 4, this guy's 30. All of these numbers, not counting 4 and 30, are completely valid for this. 4 won't work because 4 isn't greater than 4. So, cool. Alright, I'm going to do one more. What I want you to do is copy down the problem and then hit pause, solve it all out for yourself, and then hit play and make sure you get the same answers. Alright, oops, what did I just do? I want to move it. Whoops, I don't want to exit. Okay, I'll draw an amazing triangle. Ready? Fasten your seatbelts. Woo! So cool. Alright, let's say this guy's 21. Clearly this looks like a 4. Yeah. And then that's x. Alright, so find what values of x or can be used to make this a valid triangle. Hit pause and figure that out. Alright, the first inequality is that 4 plus x has to be bigger than 21. And the other one has to be that 21 plus 4 has to be bigger than x. Again, we don't need to worry about 21 plus x being bigger than 4 because it already is. So for this inequality, we subtract 4 from both sides. 21 minus 4 gives us 17, so x has to be bigger than 17. 21 plus 4 gives us 25, so x has to be less than 25. So it's not a huge range for this guy. This particular triangle, this x is pretty narrow if you think about it. Here's 17, here's 24. It's not too many numbers in between those guys. Well, I mean, tons of decimals, sure, but not whole numbers or integers. So, alright, I hope that helps. If you have any questions, come find me.